this is Captain Chaudhary. In my last video on Kelvin Deflector, we had conducted an experiment whereby the ship was made to steer by compass on north, south, east and west, and we were able to compare the magnetic field strength while the vessel steered north versus the south and east versus the west. It was like we were holding the card with a standard deviation of 90 degrees on all these four headings. All these four headings, the standard deviation was always 90 degrees, but the readings were different. So for causing that standard deviation of 90 degrees, what is the reading on north and what is the reading on south? That indicated whether the field while the ship was heading north was stronger or while the ship was heading south was stronger. Like suppose we had conducted an experiment and the readings obtained were as follows: north say 26, south 22, west 20 and east 16. Now when we compare north and south readings, it shows that while the ship was heading north, the field was stronger as compared to when the heading was south. It means that the ship has got a red pole aft and the blue pole forward. So internally the field which runs this way, Earth's field always being from south to north, the two field they get added, and that's why the figure on the reading on north heading is more than the reading on south heading. On the south heading it would be like this. Internally the field is opposite to the outside field. This is the reason that on south heading you get a reading of 22 and on north heading it is 26. Now this is with respect to north and south. We will also analyze what happens when the vessel is heading west versus when the vessel is heading east. When the Earth's field is always from south to north. But we can see while the vessel is heading west, that is this particular heading, the field is stronger. Field is stronger means there is something within the ship which is supporting the field outside. The field within the ship is from port to starboard, right? This means there is red on port and blue on starboard. On this heading, while the red goes here and blue goes here, internally the field is going from port to starboard. This is the reason that on the easterly heading the reading is 16, which is less than the reading on westerly heading, that is 20. Having understood these diagrams, let us conclude that there is blue forward and there is blue on starboard. Now we know from our earlier studies that when the blue is forward, starboard or below, it gives rise to positive coefficient. So when the blue is forward, it means that there is plus PB present on ship. When the blue is on starboard, which is our present case, right, there is plus PC on board. One other thing which we must understand is the total of reading on north-south is 48 and total of reading on east-west is 36. North-south is more than east-west. It means that there is plus D on board. This indicates that there is plus D. So what we understand now is there is plus PB, there is plus PC and plus D. So let us see what can be done to neutralize these values, right? Plus PB, plus PC and plus D. So Now the mean of north and south readings is 24. 24 is the mean of north and south reading, and 18 is the mean of east and west reading. The Kelvin deflector magnet will be oriented 350, 170. That means the blue of Kelvin deflector will be on 170, something like this. This is outer reading 0, 90, 180. And the inner readings will be this way. So what we want is the Kelvin deflector be oriented like this, right? With blue over here and red over here. 24 is the reading, right? Suppose this is the underside of the binnacle. We will insert the magnet, and by trial and error we will place the magnets, number of magnets or the slots of the binnacle. We will place the magnets with red forward, suppose this is forward direction, and blue aft, in such a way. That means number of magnets or the slots that we will use. This is forward, this is aft. The red forward, because we know that the ship has got blue forward. We'll place these magnets or a magnet in such a position that the standard deviation shown is 90 precisely. That means the correctors are giving the negative PB, the ship's PB being positive. So PB is corrected now. Let's do the same thing for east and west. The ship has got blue on the starboard side, which means that the ship has got plus PC. So we are going to place the magnets, athwartship magnets, with the red on starboard side, so that it is opposite to the existing PC. So correctors are going to give minus PC. Let us head the ship east. The same way, the AB is asked to steer by gyro so that we maintain the east by magnetic compass. Now Kelvin deflector's blue leg is placed on the north of compass, and it is dragged once again by 170 degrees. The Kelvin deflector leg is turned. For the reading of 18, what we do is we place the thwartship magnet in number or the appropriate slot with red on starboard side and blue on port, in such a way that the standard deflection once again is 90 degrees. When we do this, this means that the corrector is applying equal PC in opposite direction. That means the corrector is applying minus PC, the ship had plus PC, and the PC is corrected now. Now the mean of north, south, east, west, that is 21. Yes. So what we do is we can pick up one of the cardinal headings. For example, we might steer north. Once again, the Kelvin deflector will be oriented 350, 170, with the reading on Kelvin deflector as 21, which is the mean of north, south, east, west. Both the spheres are symmetrically moved inwards so that the standard deflection comes to 90. When you have done this, this means the D is also corrected. Now, what is the principle behind this? The ship inherently has plus D, and the correctors, they provide minus D. But in spite of the correctors set approximately, the ship is showing plus D. That means there is a presence of plus D. How we come to know there is presence of plus D? Because the north-south total of north-south reading is more than total of east-west reading. That means plus D is present, which means that the spheres are under correcting. Because in spite of spheres giving minus d, the ship still has plus d. That means the spheres have to move inwards, and when the spheres move inwards, they will give a stronger minus d at some point of time when the standard deviation is 90. We would say that the spheres are neutralizing the plus d of the ship, and d this way is corrected. As you have seen, this particular adjustment of the compass or the characters is based on the comparison. Number one. And number two, it assumes that ship does not have coefficients a, e, and ic.